6th grade, Module 5, Lesson 13, Classwork. Example 1. Determine the volume of a cube with side lengths of 2 1/4 centimeters cubed. So a cube has all sides that are the same length. So the length, the width, and the height are all going to be the same for a cube. So we would have 2 1/4 centimeters times 2 1/4 centimeters times 2 1/4 centimeters. So I'm going to make them into improper fractions. 2 1/4 would be equal to 9/4. So we have 9/4 times 9/4 times 9/4. And 9 times 9 is 81. Times 9 is 729. 4 times 4 is 16. Times 4 is 64. So we get 729 64th centimeters cubed. If you want to make that into a mixed number, which I always like to do because it just seems to make more sense, we'll divide. We get 8, bring down the 9. 64 goes into 89 once. So we also get that is equal to 11, and we have 25 left over out of 64 centimeters cubed. Example 2, determine the volume of a rectangular prism with a base area of 7/12 feet squared and a height of 1/3. So remember, base area, to find the area of the base, we do length times width is equal to the base area. So all we need to do is multiply it by the height. So let's do 7/12 feet squared times 1/3 of a foot is going to be equal to the volume. So 7/12 times 1/3 is equal to 7/36. It will be feet cubed. Exercises. Number 1, use the rectangular prism to answer the next set of questions. Determine the volume of the prism. Okay, so we know the area of this, right here, the area of the base is 13/2 feet squared, and the height is 5/3. So we can multiply the area of the base. Volume is equal to area of base times height. Again, because the area of the base, that is already length times width. They've already done that for us. Makes it easier. They took out one of the steps. That's awesome. So volume is equal to 13/2 feet squared times 5/3 feet. And 13/2 times 5/3. 13 times 5 is 65 sixths. So we get 65 sixths feet cubed. And we could, I'm going to go ahead and make that into a mixed number. Six can't go into 5, so we get 10 and 5/6 feet cubed. Determine the volume of the prism if the height of the prism is doubled. So this is doubled times 2, or otherwise that is 10/3 instead of 5/3. We would do the volume is equal to 13/2 feet squared times, we doubled the volume, so times 2, we got 10/3 feet as the height. We would get 13/2 times 10/3. We would get 130 sixths, which, if you notice, is double 65 sixths. So that would be equal to, let's see, 130 divided by 6. Can go in there twice. In there once. 21 and 4/6. Or 21 and 2/3 feet cubed. C. Compare the volume of the rectangular prism in part A with the volume of the rectangular prism in part B. What do we notice? Well, I already noticed it. It is double, so the volume in part A is double the volume in part B because we doubled the height. So we're going to have a whole nother one sitting on top of there that is the exact same size. We can say that when the height is doubled, the volume is also doubled. Right, 21 and 2/3 is twice as much as 10 and 5/6. D, complete the table below. Complete and use the table below to determine the relationship between the height and volume. Okay, so here it looks like we have 5/3 and then they doubled it. And this doubled. And then from 5/3 we went to 15/3, so they tripled it. And then here they've quadrupled it. So if we had 5/3, let's see, the area of the base was 13/2. So we do this times 13/2. 15/3 times 13/2 was 15 times 13. Is 195/6, and they didn't reduce any of these, so I'm going to leave it at 195/6, and then 20/3 times 13/2. What is 20 times 13? We get 260/6. What happened to the volume when the height was tripled? So when the height was tripled here, on this one, when we tripled the height, then the volume was also tripled. So we can say the volume was tripled. What happened when the height was quadrupled? So here, this one, what happened when it was quadrupled? Well, the volume was quadrupled. Right, the volume of this is 4 times as much as the volume of the first one. What conclusions can you make when the base area stays constant and only the height changes? So when the base stays the same, like it always has, it was always 13/2, but the height is the only thing that's changing, then the volume is going to change at the same rate that the height is changing. So each time, let's say, each time the height is multiplied by a number, the original volume is multiplied by the same amount. It is a proportional relationship. So I'm just going to say, put in there, proportional relationship. Meaning when you do one thing to the height, it's going to do the same thing to the volume. Number 2, if B represents the area of the base and H represents the height, write an expression that represents the volume. So if B represents the area of the base and H is height, an expression that represents volume. So we would do B, the area of the base, times the height, BH. If we double the height, write an expression for the new height. So we double the height, we have twice as much height, so that would be 2H. Write an expression that represents the volume with the doubled height. So we would do 2, the area of the base, times 2 height. So that would be the volume if we doubled the height. And then D, write an equivalent expression using the commutative and associative properties to show the volume is twice the original volume. So I'm going to take the 2 out. So commutative property means that I can move them around. Since we're multiplying all of them, I can move them around in different orders. And then associative, I'm going to group them with different groupings. So 2 base times height. So we would multiply the area of the base times the height and then multiply it by 2. So we use the commutative properties by switching places, and we use the associative property by grouping them with the parentheses, which we can do because it doesn't matter for multiplication what order they're in or how we group them. To multiply, we're going to get the same answer in the end. Number 3, use the cube to answer the following questions. Determine the volume of the cube. Remember, the volume of the cube is the same distance all the way around, same length, width, and height. So the volume is length times width times height. So the volume of this would be 3 meters by 3 meters by 3 meters. So 3 times 3 times 3. 3 times 3 is 9. Times 3 would be 27 meters cubed. So the volume of that would be 27 meters cubed. B, determine the volume of a cube whose side lengths are half as long as the side lengths of the original cube. So if we found half of that, I'm just going to divide them all by 2. We would have volume would be equal to 3/2 meters by 3/2 meters by 3/2 meters. So 3/2 times 3/2 times 3/2 would be equal to 27, and 2 times 2 is 4, times 2 is 8, 27/8 meters cubed. C, determine the volume if the side lengths are 1/4 as long. So now we're splitting them into fourths. So the volume would be, instead of 3 meters, we're going to do 3/4 because we're dividing them all into fourths. So we would have 3/4 meters by 3/4 meters by 3/4 meters. 3/4 times 3/4 times 3/4. 3 times 3 times 3 is still 27, but 4 times 4 is 16 times 4 is 64 meters cubed. D, determine the volume if the side lengths are 1/6 as long as the original cube's side lengths. So we're going to do the same thing, but this time we're splitting them into sixths. So we would have 3/6 meters by 3/6 meters by 3/6 meters. Or you could do 1/2 by 1/2 by 1/2, which I'm just going to reduce it to 1/2 times 1/2 times 1/2. We get 1/8 meters cubed. E, explain the relationship between the side lengths and the volumes of the cubed. Okay, so since all of the side lengths were changed by the same fractional amount, so all of the cube lengths were half as long, all of them are 1/4, all of them are 1/6, we're changing all 3, not just 1. Whereas in the previous example, we were only changing the height. Now we're changing the length, the width, and the height. So that means that it's going to get even smaller or larger proportionally by all 3 different sides. So let's say all sides were changed by the same fractional amount. So the volume changes by 3 times that amount. So for example, if we change each, now I'm forgetting how to spell, each side by 1/2, then altogether we have, let's say we have changed it by 1/2 times 1/2 times 1/2, or 1/8, because you have to count for all 3 sides. So let's do some more examples of that. Hopefully that'll make a little more sense if you didn't quite follow that. So check to see if the relationship you found in exercise 3 is the same for rectangular prisms. So to determine the volume of this, we would have length times width times height, because they didn't give us the area of the base. So volume would be equal to 9 feet by 2 feet by 3 feet. So 9 times 2 times 3 would be equal to 9 times 2 is 18. 18 times 3, 8 times 3 is 24, is 54. 54 feet cubed. B, determine the volume if all the sides are half as long as the original length. So now all of them are half. So we would have 9 halves, or 2 halves, and 3 halves. So I'm dividing them all by 2. 9 halves feet by 2 halves feet, which I'm just going to change that to 1 because that's 1, and 3 halves feet. So let's do 9 halves times 1 times 3 halves would give us 27/4 feet cubed. So what happened there is it got, well, if we make that, it'll be easier to see if we make it into a mixed number. So let's do that. So 27/4, 4 can go into 27. Let's see, 8 times 4 is 32. 6 times 4 is 24. 6 3/4 feet cubed. So if we're comparing the 54 feet, and then when we took them all and cut them in half, it got significantly smaller, going from 54 feet cubed all the way down to 6 3/4 feet cubed. So it didn't just get cut in half, it actually got cut into eighths because we cut them all in halves. And when we cut them all in halves, we actually are coming up with 1/8 of 54 feet cubed because we have to take every single side into account. So determine the volume if all the sides are 1/3 as long. So now if we divide them all into thirds, so we'd have 9/3 feet by 2/3 feet by 3/3 feet. I'm going to reduce these. So 9/3 is equal to 3. So we'd have 3 times 2/3 times 3/3. That's just 1. We get 6/3, which is actually equal to 2 feet cubed. So now when we took 1/3 of all of them, we went from 54 all the way down. Now we're at 2. So it got even smaller. And it actually, what happened was we took 1/3 of a length times 1/3 of a length times 1/3 of a length, and we got 1/27. So 2 is 1/27 of 54 because we had to take 1/3 of all the sides. D, is the relationship between the side lengths and the volume the same as the one that occurred in exercise 3? Explain your answer. So yes, it would be the same because, and let's go back to exercise 3. So here, when we were taking, let's see, here we did half as long, a fourth as long, a sixth as long. So it's the same proportional relationship as we did before. This time we were just taking thirds and halves, whereas before we were taking fourths and sixths. So let's say yes, the relationship that was found is still true. When I found the volume of a prism with 1/3 the original side lengths, the volume was 1/3 times 1/3 times 1/3, or to the third power, which is equal to 1/27th the original. Like we talked about right there. Okay, number 5. If E represents a side length of the cube, write an expression that shows the volume of the cube. So E is a side length of the cube. Remember, a cube has all side lengths that are the same. So we would do E to the third power, or you could write E times E times E. Either one. B, if we divide the side lengths by 3, create an expression for the new side length. So if we divide the side lengths by 3, so we're going to divide all the side lengths by 3, we would do 1/3 for how would we find an expression for one new side length? 1/3 of the side length, 1/3 of E. C, write an expression that represents the volume of the cube with 1/3 the side length. So now we want the volume of the whole thing. So I would do 1/3 of E 3 times. 1/3 E times 1/3 E times 1/3 E. Or you could write it as 1/3 E. If you want to actually write it out, 1/3 E, 1/3 E. Either way, they mean the same thing. Write an equivalent expression to show that the volume is 1/27th of the original volume. So let's just work this out. So 1/3 E to the third power would be, like we said before, 1/3 E times 1/3 E times 1/3 E. So if I just start multiplying it, 1/3 E, let's do 1/3 times 1/3 times 1/3, gets me 1/27th, but then I have 3 E's, so 1/27th E to the third power, 3 E's.